Hi students, it's Miss Medina and I'm going to show you how to rearrange equations with multiple variables. So this is normally known as a literal equation. Okay? So solve for the variable indicated in number 1. And we have that 9w equals 4x and we're solving for w. I know there's multiple choices, but right now we're learning. All right, so when we look at this, this is your left side, this is your right side, clear? And on the left side, you're multiplying 9 times w, and on the right side, you're multiplying 4 times x. And we want to isolate the w, right? Because that's what we want to solve for. All right, so 9w equals 4x. This is the variable that we want by itself, but this variable is currently being multiplied by 9. How do we undo multiplication by 9? We have to do division by 9. So we're going to divide the left by 9, and we're also going to divide the right by 9. These 9s, 9 over 9 is 1. So we end up with w equals 4x over 9. You can also rewrite this as 4 over 9x. W equals 4 over 9x. Which means it's that one. All right, number 2. Number 2 says, what equation do you get when you solve qx plus rx equals s for x? All right, once you hit literal equations, it's like algebra gets very serious. All right, so qx is q times x plus rx, and that one is r times x, equals s. All right, so you see how these two terms both have an x in them, right? Here and here. So this came about because an x was distributed here. So we're going to undo the distributive property. All right, so the x got distributed, so we're going to pull out the x. See? Think about it. If you multiply it in, you're going to end up with xq or qx times xr or rx. Okay. All right, so now that we've undone this, this is multiplication, right? Let me rewrite this. This is x times q plus r equals s, right? And how do you undo multiplication? Right, this is the one that we want. We undo multiplication by division. So since on the left we're multiplying by this quantity q plus r, then we need to do division by q plus r. And whatever we do on the left, we also have to do on the right. All right, this cancels here. We're left with x equals to s over q plus r. And we go looking for the answer. This one is right here. number 3. What equation do you get when you solve the equation, this one, for h? Okie dokie, here we go. Change color. RS, that means you're multiplying the R times the S, plus H squared equals L. And we want to solve for H. Well, the good thing is that H only happens on this term right here. So we want this term to be the only one on the left-hand side, which means we have to get rid of RS. Right, so how do we undo addition? Right, subtraction. All right, so these cancel because they're additive inverses. We have h squared equals, and these right here, they're not like terms, so we can't combine them. So we have to keep them separate. And so this is h squared. What's the opposite of squaring? All right, so the opposite of squaring is taking square roots. So what we want to do is we want to take the square root on the left, and we want to take the square root on the right. So what ends up happening is that this square root cancels the square, and we're left with h. All right, let's look at the choices. Square root of L minus RS. Oh, right here. Ooh. Okay, number 4. What equation do you get when you solve this for G? All right, well, once again, we have G in multiple terms. Right, we have G on this one, and on this one. So what we need to do is just like in the 2 problems ago, this was, since it's in every single term, that means it was distributed into all those terms. We need to undo the distributive property, and so we're going to pull this out. We're going to factor it out. Right, when we pull out the G here, you have an H left over. When we pull out this G, you have a minus T left over. And when we pull out this G, you have a 1 left over. Right, so think about it. When you distribute this, you're going to get the GH, you're going to get the minus GT, and you're going to get the plus G. All right, so we know we're right because when we distribute it back in, we get this original terms. Here we go, and once again, this is multiplication, right? So I'll move my, I'm sorry. See? So since I want to get just the H by the G by itself, that means I need to undo this multiplication by this quantity. So I need to divide both the left and the right by H minus T plus 1 by H minus T plus 1. Right? This cancels this. And we have that G equals T over H minus T plus 1. Okay, good. They all have a T in the numerator. And the bottom has to be H minus T plus 1. So it's going to be this one. Ooh. Number 5, xy plus 7 equals n. All right, and the variable that we want is this one. Okay. So our y is being multiplied by x, and then we're adding 7. So we're going to subtract 7 from both sides. Right, so we have x, y equals. So these are not like terms. And then the final step, since we want to isolate the y, is to divide both sides by x. And so you get that y equals n minus 7 quantity divided by x. So it would be that one. All right, so we have for number 6, we have this equation and we want to solve for c. So that c is inside that parenthesis, so we're going to have to get inside the parentheses quickly. Okay, so let me copy the equation. All right, let's see. Well, let me copy the problem over here. A equals 1/2 times b plus c times h. And we're trying to solve for c. All right, so before we can actually go inside of the parentheses, we have to get rid of the stuff that's being multiplied. And remember the commutative property over multiplication? It doesn't really matter which one we get rid of first. So let's get rid of the 1/2. How do we get rid of 1/2? We multiply both sides by 2. Because then this cancels this, right? So now we have 2a equals b plus c times h. All right, again, we're trying to solve for c. Before we can go inside the parentheses, we have to get rid of this times h, which means we'll need to divide by h on both sides. And that cancels this. So we have 2a over h equals, now that all we have is the b plus c, we don't really need the parentheses anymore. And now we just need this one. And since this is addition, the opposite of addition would be subtraction. I need more space. Let me scroll down. All right, so this one and this one, they're not like terms, so we cannot combine them. So 2a over h minus b. So then this one's the answer. Whew, I know this stuff is intense. All right, number 7. We have x over y plus 9 equals n. And we want to solve for y. Okay, before we can get to the denominator, let's isolate this term. So that means we need to subtract 9 from both sides. We have x over y equals n minus 9. Okay. All right, so we have y in the denominator. And we need to move it to the, I guess, we need to not have it in the denominator. So we're going to multiply both sides by y. Okay. But when you do this, you have to be very careful that you're treating this as a quantity. The y's cancel. And we're left with x equals n minus 9 times y. Okay. Now we can have y by itself, but we have to get rid of this n minus 9. And you see whatever I'm doing on the right side, I have to also do on the left. We have y equals x over n minus 9. Whew, I was getting worried. I was like, oh no, is the answer not there? There you go. So it's B. All right, next example. There's only 10. Okay, whew. All right, number 8. We have 4x minus z equals y. And we want to solve this for x. Okay, this one isn't so bad. Right? So this is the term that has x, which means this minus z has to move to the other side. These are additive inverses, so they cancel. We have 4x equals, these, they're not like terms, which means we cannot combine them, so we're going to have to write them separately. And then lastly, we want x by itself. So to undo this multiplication, we need to do division here. So x is going to be equal to y plus z quantity divided by 4. Y plus z quantity divided by 4. So it's going to be this one. Number 9. This one's a very important concept here. So we have y equals mx plus b. And we want to solve for m. Right, so m is in this term, which means we need to subtract b from both sides. All right, so these are like terms, so they cancel, but these are not like terms. So you can have y minus b equals mx. And remember, we're isolating m. That means the x has to go. Ooh, I almost wrote x equals. M equals y minus b over x. Right here. right, the last one. Wait, didn't we just do a problem like this one? X over y plus 9 equals n. And we're trying to solve for y, right? So that means we need to subtract 9 from both sides. So we have x over y equals n minus 9, right? As a quantity, we'll multiply both sides by y. We get that x equals n minus 9 times y, and then we divide by n minus 9. X over n minus 9. Ooh, all right.